My name is Leo. I work here at Uber. I work at the web platform team. I was one of the developers for Fusion.js, which is a framework that we're going to be talking about today. It's basically a plugin-based web framework for universal web apps. And when I say universal, that goes into a little bit of performance profiles that a website can have. So a universal website basically allows you to server render a part of your application using the same code that you use to render that same page on the client. You could send out HTML first and have the browser parse that with the native engine. And that speeds up the time to first byte or the first pixel. And once you're on the browser and the JavaScript is run, then you can route to different pages, and the code that renders the new pages are exactly the same, and it's all a single page application. And basically, it allows you to reuse the same code for this performance optimization, and also to maintain maintainability of your application. So one of the rationales for developing this framework was that historically, as many of you probably know, web technologies, they move pretty fast, right? There's new technologies coming out every year. There's module reloading, there's code splitting, there's CSS and JS, there's different types of compression. So every year there's something new, and it can be challenging for a company of size of Uber or Facebook or Google, where there may be possibly hundreds of projects going on at a time, to sort of keep up with all of these technologies and still be able to maintain them and upgrade to new technologies as they come along. So just a bit of history. We used to use this framework. It's a proprietary framework. We had about 600 projects using it, but it has some issues. It was a few years old, and it was difficult to test. It was difficult to implement new technologies on top of it, implement new optimizations. So for example, bundle splitting is something that a lot of people want to do because their app is starting to push 1-2 megabytes of JS bundle size, and then they'll think, oh, what's the easiest way to fix that? Maybe we'll just split the JavaScript into different parts and only load the parts that we need. But this requires a little bit of machinery. You have to do some fiddling with Webpack or something like that, just so you can stitch all of your modules together in a correct way and send the correct bundles to the browser. And if you were using Gulp 2 or 3 years ago, then obviously migrating to Webpack might be a little bit more difficult to do. You want to be able to support all of these hundreds of projects, and at the same time, you don't want everyone doing something slightly different, because then you can't actually support them at all. So what we did is we created this new framework. We took a bunch of lessons from our previous framework, and we decided, well, we can't just have this monolithic thing, because it's really hard to pull things out and put other things in. The abstractions don't necessarily make sense. Maybe there's leaky abstractions, maybe there's too much coupling in some areas, and it becomes difficult to upgrade things separately. So what we wanted to do with the new framework was to basically create plugins so that we could individually pull things in and out from an application, and be able to version each of these things, similar to how some of the popular projects in the JS ecosystem do these days. So Webpack has plugins that you can just sort of add into your project, and that will just add some functionality to it. Babel has a similar infrastructure, and so does Rollup and a bunch of other projects. So we wanted to borrow that idea and bring that into some higher level framework, where you would have, for example, React and Redux, and maybe you need to do things related to what Marcel was saying, like browser performance metrics. Maybe you want to do some security, you want to do CSRF protection, or maybe you want to do translations, or maybe you want to do routing. There's many different concerns that you want to do. And keeping in mind that you wanted to take advantage of different performance optimization, such as server rendering and bundle splitting, it can be pretty difficult to implement this in a modular way, right? Because let's say you're doing a translation system and you want it to be performant when you have a bundle splitting situation. So you may have 10 different pages. Each of them has a specific set of translation keys that they need to use, but you don't necessarily want to load all translations for all pages, for all languages into your bundle, because that'll just be huge and it just wouldn't load properly. So you want to just be able to, at a compile time, figure out, well, what are the translations they actually need for this one page, and then bundle that into the JS bundle. And on the server, you want to be able to say, well, I actually need to also render this as an HTML thing. On the browser, you need to say, well, if I came from some route that that was just navigated via JavaScript, I also need to be able to render that somehow. So if you're just naively building this, you're going to be touching a lot of different files everywhere in your application. And as I said, if you have 100 different projects, if you let people do it on their own, then you're just going to have a lot of different implementations. And that doesn't scale, because now if somebody has a bug somewhere, then fixing that bug only benefits their own team. And ideally, we want to be able to say, well, let's just centralize all of that, have one team own translations or routing or whatever it is, and have that be a version package. It's a standalone thing that can be maintained by just one team that can benefit all of the other 100 teams. But also at the same time be easy to install and uninstall if they don't need that functionality. So that's kind of the idea for a plugin system. So the plugin system in Fusion has it uses dependency injection. If you guys use Angular, you probably have heard of something similar to that. There's similar systems in Java and C Sharp. Basically allows you to inject a dependency saying, I need this thing that has a certain interface in order to work. And the benefits of dependency injection are that you can then mock the dependency if you're doing tests. So if you're doing an integration test or end-to-end test, you can say, well, actually, I don't want to log things to my production servers, or I don't want to call my endpoints, or I don't want to do something when I'm doing a test. Dependency injection lets you write tests in a much more modular way, and you don't necessarily have to worry about what things exist in the system and what don't. This is facilitated a little bit by static typing. So for Fusion.js, what we use is Flow.js, which is a type system that was developed by Facebook. One of the nice things about that is that it does type inference. What that means is that you can sort of hide types in your files, and you can gradually migrate from old code into new code. And this is something we're actually been doing internally. We wrote migration scripts from our old framework into the new framework. And old code can be 3-4 years old, even potentially even older. And obviously Flow.js wasn't around at that time. So you might potentially be looking at several projects that have no flow coverage whatsoever, or any type coverage. And being able to just say, well, I want to just gradually migrate this. It was a very interesting appeal to Flow.js. What we can do then is we can say, well, let's migrate all of this code just via code mods, and have the Fusion.js part be statically typed. And that lets us say, well, I'm going to now use a logger, and this logger has an interface, and this logger is statically typed. And if I make a mistake somewhere, then the type system will catch it. But I still have all of this other code that I can still run, and it's not going to blow up if I try to run this code, even though it's not typed. You kind of get the benefits of both worlds. The other part of the plugin system that lets it sort of encapsulate the whole thing is network isolation. So one part of the system that is encapsulated by a plugin is middleware. I don't know how many people are familiar with Express.js. I'm pretty sure most people probably have at least heard of it. Anyways, if you've heard of Express.js, if you used it, then you know that it's typically you would read the request object, and then you would just sort of do a response dot send something, and it just kind of just flushes it out to the browser when you do that. But the problem with that is that the API tends to lend itself to mutation. So if you have several things that you need to do, you need to do logging, or you're going to send some headers or whatever. Each time you pass through a middleware, then some side effects going to get triggered. And now it's very difficult to figure out, well, what exactly is going on with my middleware stack? How do I test this? Has this thing been run before? Do I need it to test my module? It becomes difficult to figure out, well, should I have run this side effect before I ran my code, or should I have run this code before the side effect, and things like that. So what Koa middlewares give you is they sort of just give you a state bag. You can just modify things willy-nilly. You can say, well, the body is now hello, and then later on you can say, actually, no, the body is going to be something else. And it basically just becomes an input-output kind of situation. You can just say, here's my state. It's going to give you back a different state, and then you can just assert on that. And it makes it a lot easier to test, like a network interaction. So here's sort of an example of the dependency injection system. So it's basically based on tokens. If you've used different dependency injection systems, you might have seen that they're based on either a type or a string. Because we want it to be backwards compatible and allow people to use it without a type system. There's two options. One is to use strings, but then you'll run into issues of, well, what if I have two different loggers? How can I resolve that conflict? And if you have two things that are called logger, then you just can't have that. There's a collision and it doesn't work. With tokens, you can basically have as many tokens as you want. The namespace is basically infinite. So you can have tokens that have the same name, quote unquote, but they are different entities. So that solves that issue. The token becomes a handle that you can use to reference to that dependency. So here I have a create plugin on this line here. In this case, I'm calling it a team service. It takes a user service and a project service, and then it just provides a interface. In this case, it returns a function that calls some functions on the project, calls some functions on the user, and then returns a result. So it's all self-contained. It says, well, for this module, I need a user, I need a project, and I'm going to return something with this interface. And you can have everything be typed. And once you write a test for it, then you can say, well, actually, I know for a fact I only need user and project. I don't need a logger. I don't need other things that may be in your system when you're building an application. And this makes it easier to test, which was a problem that we had before. We basically had this huge global object that just kind of had everything in it, and it would just get passed into all of the different parts of the system. And then when you're trying to test, you didn't know, well, do I need to have a logger here? I'm not really sure. And it was difficult to find out what you actually needed to test any part of the system. And this makes it a lot easier. Talk a little bit about middlewares a little bit more. So the concept of a middleware in Koa is it's basically a function, an async function. The CTX variable is a context. It's basically a state bag. Fusion extensive with a few more useful properties. For example, element is something that you can use to your DOM representation. In this case, it could be a React element. You can basically set status, you can set body, you can check for the path, and you can basically look at the state and you can modify the state. And then you can call return next. Next here is an asynchronous function. it represents a rendering. If you're using React, for example, it will represent React rendering or React DOM render. If you're using a different view framework, then it will just use the render of whatever that view framework is. And because of the plugin system, even the rendering library they use is also something that you can plug into the framework, so it doesn't necessarily need to be React. In this case, what we're doing is we're checking if there's an element, if the path is equal to that, and then if it is, then just returns a 200. It's basically just a health check. But it can be a bit more complicated. You can say, well, maybe I want to render my React tree. I want to see, well, what was the router path that I hit? What was the parameters? How do they resolve? And so on and so on. And I want to get all of that back from React. You need to do that after the render call. And then I want to put that in the head of the HTML because I want to sort of render that thing. So that can happen after the next call. Koa kind of makes it easier for you to reason about what happens before and after render. So this is kind of a benefit over Express. Remember in Express, you kind of just say, you call next, and then it just kind of goes away. You have no control over it anymore. With Koa, it's a little bit different. You can say, I want to do some things, and then I want to render. And once you're done, I can do more things. And then I'll yield to the next middleware. What they call that is a downstream and upstream. So you can basically have things happen in kind of like an onion layer ordering. So you can say, I want to do things before rendering for this particular concern. Maybe it is routing, maybe it is translations, whatever it is. And then I run a render, and whatever I need from the rendering, I can do on the upstream. And it's sort of all self-contained within that one plugin. And then the same thing for each other plugin that I add into the system. So if I want to have something that's specifically to routing, then I have that downstream, upstream infrastructure for that one plugin. But if I want to do that for translations or for something else, then I can have the exact same paradigm, and it's isolated from the routing or from whatever other thing. Since it's all self-contained in the plugin, then once I register that plugin, then all of that is already automatically set up for me. I don't necessarily need to go and add code to a million different places in the code base. As I mentioned, there's obviously benefits to having a plugin system that is modularizable. One big one is testability. Fusion, the CLI package, comes with JS out of the box. It has some configuration that makes it easier to get started with. For example, it lets you write tests that are server specific or browser specific, and just gives you like some utilities that you can use. For example, for simulating a request, instead of like actually launching your server and sending a network request and seeing what that looks like, you can sort of mock the whole thing. You mock the entire network out, and you can say, well, I'm just gonna send a thing that looks like a contacts, send it into middleware, get it back out, see what it looks like, and it makes for easier and faster tests. And the dependency injection comes into play as well. You can obviously mock each of the dependencies that you need, and because of the type system, you know what they are. And then obviously you can use Enzyme or Puppeteer and other tools that for various different levels of testing, and Enzyme for unit tests, and Puppeteer if you want to do more end-to-end or integration tests. So here's sort of a slightly outdated slide, actually. I was looking at it recently. I wrote here 60 projects, but it's actually a little bit more. We're about 200 projects now. There's a lot of plugins that people have been writing, and there's also a lot of actual web apps. And it's sort of the default framework that we're going to be using for all of the projects going forward. We released this externally in August, but we're actually having internally since I believe it was January. And then, as I mentioned, we wrote automation migration scripts, and that converts our code bases. There's about 600 of them over to Fusion.js. So that also contributes a little bit to that 200 number. There's some other things they're working on. Something that I'm pretty excited about. We're kind of refactoring the compiler a little bit. It's going to allow us to do browser-specific bundling. Just basically allows you to say, well, if you're on Chrome latest version, you probably don't need to transpile everything like arrow functions or classes or promise polyfills. You don't need any of that to be sent to the browser. So we can just generate a bundle that is optimized for Chrome. We can do that for different browsers, and we can make it pretty granular. So this is something that we're interested in providing. It's going to be useful for the consumers, because if you have like 100 projects, then if you have an optimization at the level of the framework, then just by pushing a new version, everybody can benefit from that. We're also working on service workers. We've got a proposal out for doing client hints and some other interesting things also. Here's our website if anybody wants to check it out, fusionjs.com. It's an open source project, MIT license. It's on github.com/fusionjs. And we also have a Slack channel. If you go to the website, there's going to be a link to community and you can check it out. So yeah, pop by and say hi. And yeah, we're always interested in what people think of it. And if you want to try it out and give us feedback, that would be great. Thank you much.